Thank you. Thank you. I have to say it's my first time at PyCon Italy, so of course I didn't know what I was missing. So it's nice to be here. It's nice to meet you. A few words about me before we kick off. So I've been a software engineer for 7 or 8 years, and then I kind of went back to school. I had my PhD in information retrieval, and back again to industry. So right now I'm kind of trying to merge the best of both worlds, so the academic research and the engineering side. In terms of stuff I'm working on right now, I'm wrapping up the first draft of my first book with Path Publishing. Hopefully should be out over the summer, so quite an interesting experience. And as Valerio mentioned earlier, I've been trying to get more involved with the community, and usually you can find me at the local meetup. We have a very nice community in London. PyData every month, a nice meetup, and this year I've been part of the review committee for the conference that is coming up in about 3 weeks. It kind of is coming and going. Valerio? Coming and going. Can you hear me well in the back? Yeah? Okay. So, building data pipelines. Initially, when I was thinking about the proposal talk, I just had in mind an introduction to Luigi, which is one of the tools I'm going to mention. Then I tried to look at the bigger picture, and then I took another step back, and things got a little bit philosophical. So that's my starting point. R&D is not engineering. If you remember, yesterday we had a nice talk on scikit-learn machine learning model in production, and one of the messages was, if you are a data scientist, you're not a DevOps. And then kind of starting from the same point, if you are a data scientist, or if you are a research scientist anyway, you're not a software engineer. The question is, can we meet in the middle? And this is important because your R&D results, when they're good, action. So we should find a way, is a process of going from prototyping into production. As we define our industry, so what is data science? We all know we kind of spend a lot of time with data quality issues. The joke is 80% of your time is gone preparing your data, and so 80% of your time preparing your data, and the remaining 20% complaining about the time you spend preparing data. So it's a bit of a joke, but that's how often things are. And in my experience, I've been talking with many companies, and it doesn't matter if they have big data or not. Usually they have big problems with their data. So what I'm trying to say here, and what Borat is trying to tell us, is data quality is a big issue. Okay, so preparing your data is important. So building data pipelines. I'm kind of borrowing the terminology from data warehousing, traditional data warehousing. ETL stands for extract, transform, and load. And honestly, we never have such a linear pipeline in our systems, because usually we have many components. We have heterogeneous data sources. We need to extract data. We need to merge them. We need to clean them. We have duplicate records. We have spurious records. We have all sorts of problems. And pipelines can look very complex. This is what happens kind of before we can do our interesting stuff with the analytics. So as a goal, we want to build a good data pipeline. And long story short, for me, a good data pipeline is one that is easy to reproduce, so replicability matters, and something that is easy to bring into production. Assuming these are our goals, how do we get there? So first thing first, sometimes we hear about data sanity, and the first point is about our own sanity, really. We should transform our data rather than override our data. We should always be able to restart from scratch and replicate every step of the pipeline. And it's also important to break the big problem into smaller problems. So break down the pipeline into different components. And in terms of Python, this means creating different packages, each one for the individual components of the pipeline. So each package will have its own setup.py, and if you are kind of developing, iterating over the pipeline, it's easier to manage. Also, something important to keep in mind is we need to make sure that the individual components work individually and they work together. So we make a distinction between unit testing and kind of end-to-end testing. The suggestion is to try an end-to-end test as soon as possible. So try a full run of the pipeline as soon as you can, because that will kind of raise some problem early on, so you can iterate more quickly. But of course, you shouldn't forget about unit testing. So the individual components should work well. Now, from experience, everyone starting to work with pipelines kind of go through the same series of mistakes. You start with a tiny script, and then things will grow, and then you have a bunch of scripts. Somebody used the term script soup. So literally, you kind of throw everything together. And this is quite difficult to manage because maybe you have dependencies, you have a configuration that you have to carry over. So the way you run your pipeline with a bunch of scripts is really not convenient. You have a lot of manual steps. And if you share it, for example, with your colleagues, it works on my computer, it doesn't work on your. Did you set the environment variables? Do you have this library? Or all these kind of aspects are coming up pretty quickly. One of the solutions is to write kind of a master script where you take care of everything, and you carry over the configuration, and you set what you need to set, and so on. The problem with this approach is if something breaks halfway through, then you need to start over. And the solution for this would be to kind of introduce a manual error control or a dependency control. And what you end up with is literally reinventing the wheel, because there are already libraries to take care of this, and they're called usually workflow managers. And Luigi, that I mentioned earlier, is one of these workflow managers. Now, before moving on with workflow managers, a little kind of social experiment. So yesterday we had a talk about testing, model-based testing was really interesting. And my experience in the PyData circles, especially with people coming with a stronger academic background, but maybe a little bit less on the software engineering side, people don't write unit tests. So just as a social experiment, how many of you write the unit tests on a daily basis? Very good. Still a small proportion of the audience. Maybe a daily basis is not always the case, but at least in every iteration of what you're building, you should consider testing. And I'm talking, starting from the easy things. So unit testing, fairly easy to do. In 3 steps, you have the unit test library, part of the standard library, so you don't have to install anything in particular. Write your test, and the 3rd step is optional. You can still complain about the lack of time to write tests as long as you write your tests. So yeah, usually the excuse for not writing tests is I don't have time, it's not worth the effort, even it's not really my job. But if you want to run, sometimes you need to go slower. So unit test is really beneficial. So unit testing, we can look at it as a safety net. Your code is not a static entity, it will evolve over time, it will evolve with many iterations. So every time you touch something, maybe you're breaking something else. So you can look at your unit test as a safety net for this. And also over time, you will upgrade your libraries. So maybe some interface is going to change and you didn't notice that. So unit tests also come to the rescue from this point of view. And I'm already ranting, so there's another rant about Python 2 and Python 3. At some point, all your Python 2 code will have to go into Python 3, and that's even a bigger change than just upgrading a library. So long story short, you can use unit tests also to validate your assumption, to kind of see what you expect from your functions, from what you expect from your code. And in general, you can also look at it as a form of communication, as a form of documentation for your code. So you declare sort of input and output that you expect from the functions. And the interesting part in the long run is that you can, you're basically forced to rethink about your design. So if something is really difficult to test, maybe the design is overly complex. So you can look at it also from this point of view. Now, if you're an academic and you don't build the production software, you just want to write a paper and you do some literature review, and yeah, this is a real case. So I was reading a paper, I came across these results. Do you see the problem, machine learning people? It's a little problem here. So you run your classification or whatever kind of algorithm, you get precision and recall, and then you combine precision and recall into the F-score or the F-measure or the F1. That is the harmonic mean of precision and recall. So I expect the number to be between precision and recall, and this is out of bound. And it took me a while to spot the mistake here, and really, you know, it's quite easy to spot it with an automatic test. So you have your P for precision, R for recall, you call the function to calculate the F-score, and then once you know which one is the lower bound and which one is the upper bound, you just need one assertion to make sure that the F1 score is between the boundaries. Now, if you've never seen unit tests in action, this is not a unit test. You still need to write some code to wrap your test into a test case and so on, but really it's a small kind of boilerplate that you need. Also, you should use assertions coming from the unit test package, not the assert coming from the language. During the keynote yesterday, one of the messages was don't use assertions, right? Don't use assertion in production, that's okay, but if you're debugging your code, if you're iterating through it, it's still okay to use assertion here and there, especially if, as I said, if you're an academic and you're writing a paper and you're the only user of your code, you can use this approach that sometimes is called defensive programming. So you just slot in some assertions here and there to validate what you think about the code, what you think your variables should be, and so on. So nearly there. As I said, unit tests very important, and defensive programming, I'm not a big fan of it, but it's one option. If you know what you're doing, you can use it. As a suggestion, couple of suggestions, say no to tautologies. So tautology is when you repeat yourself. So say, if you say, I'm a Python beginner, so I just started to write Python code. So the second sentence is not telling you anything that you didn't say with the first one. If you translate this concept into testing, tautologies is when you put some logic into your test, okay? So keep your logic in your code and then test your code as a kind of a black box or mini black boxes. So don't write logic in your test. Second suggestion, avoid vanity testing. So vanity testing is what happens when you start buying into testing. You like testing, you think it's a good idea. You start writing a lot of tests and you start writing tests for everything, even if it doesn't really help you. So, long story short, writing tests is not difficult, but still it takes some effort. So your unit test should be something valuable. I mentioned earlier the unit test library coming with a standard library of Python, but of course there's a whole ecosystem for testing, and I'm not a professional tester, but you can of course benefit from the ecosystem. In particular, I want to mention coverage.py, which helps you to highlight which part of your code are not tested. Okay, so coverage is basically the proportion of lines of code that are touched by the test. And if you do vanity testing, you just want to increase your coverage for the sake of it. You should kind of look at it the other way around. So you can use coverage tools to highlight what you didn't test. Say you have an if-else statement and you run your test and it goes only through the if branch and you forgot to test it for the else. So with a coverage tool, you have a nice UI, green line, it's been tested, red line, it's not been tested. So it's quite easy to spot. Another library that I want to mention is Hypothesis. So Hypothesis allows you to write strategies. So you have a bunch of decorators. You write your single unit test and you decorate the unit test, stating what kind of input and in general what kind of expectations you have about the test. So you can easily brute force your unit test. Say you expect a string to be the input of your function, and then Hypothesis will generate a whole bunch of potential inputs, random strings, different encoding, different length, empty strings, and so on. So you can easily spot the edge cases that you didn't think about. So if you put everything together, small steps, and they will take you a long way. And yeah, that's about it. So back to building data pipelines. I mentioned the need for workflow managers, and I'm introducing here Luigi as a tool, as a workflow manager. Pip install Luigi is all you need to do to get started. If you're wondering, Luigi is Mario's brother, so famous plumber, because we're doing data plumbing. If you're familiar with Unix in general, think about makefiles and think about Unix pipes. So there is nothing new, really. So workflow manager in general allows you to define your dependencies between tasks. And in case of Luigi, you define your dependencies using Python code. So you never leave Python. You don't need to write any configuration that is outside Python. And as nice features, you have all sorts of things related to error control, checkpoint and failure recovery, meaning if something breaks, you can rerun the pipeline and it will start from the last valid checkpoint. Also, if there is a small network hiccup, it will try to rerun the task just to see if it can keep up from where it left, and so on. And what I like about Luigi is that the additional code that you need to write is really small. There's really a minimal boilerplate here. And a little cherry on top, you can also visualize your dependency graph if you are into this sort of things. So the important concept in Luigi is called task. I'm talking about tautologies. Task is a task, nothing more. So it's a unit of execution. You define your task as a class that extends the Luigi task class, and all you have to write is here. Right? You have three methods. The first one requires you define your list of dependencies, so you have to spell out the name of the task that this particular task is depending on. Then you define the output. You have to name what the output of the task is, local file, database table, whatever. And finally, the run function is the business logic of the task. And if you did break down your code into packages, basically here you just have to call, your package.run or whatever you call it. So there's nothing much to do. It's quite easy and quite straightforward. The second concept that comes with Luigi is the target. Target is the output of a task. As I mentioned, file system, local file system, S3, Elasticsearch, all sorts of databases, and either they are part of the core Luigi library or maybe they are third parties that are integrated through the Luigi contrib module. There's already a lot of off-the-shelf support for really everything. In case you have some very esoteric, hip, new kind of a database and the support is not there, all you have to do is to define your own target, which is an extension of Luigi target. And the only function here that you need to implement is the exist, which returns true if the target is there and false otherwise. So I really had a good experience with Luigi, so I recommend it, but I'm not trying to sell Luigi here. I just want to say you need a workflow manager in general. And when I was first investigating these workflow managers, Luigi was a little bit more advanced, but it's not the only one. So now Airflow from Airbnb, Mr. Job from Yelp, and Pinball from Pinterest are all interesting options, and they've been playing kind of catching up with the features. Back in the days, Luigi was a bit more feature-rich and also a bit more active in terms of open source community. Now, sometimes your pipeline will break, and if you are writing your pipelines in terms of script soup, as we mentioned earlier, probably you're also doing a lot of print for debugging, which is not the best thing. So from the keynote yesterday also, there was a mention about the login library, and the message was login is something that scares people off because it looks complex. So there's a lot of things you can do with the login module. It's not really, you can start using the login without using all the interesting features. What is nice about using login, the out-of-the-box login that you have with Python, is that you just customize your format if you want. You can include extensive information that you don't have with a print function. So for example, which module is causing which problem, which line of code, and so on. And in particular, you define different levels of verbosity. So you have debug information, info, errors, exception, warnings, and so on. Once you start using the login rather than the print, it's super easy to switch it off, right? So you don't have to go back to your code and remove all the printing, and it's quite easy to change the level. So while you're developing, you log everything, and you kind of use the debug level for login, and then once you move on with production, probably you raise your level, so you hide the debugging information. And you're not going to read the logs, probably, right? Unless you have a mechanism to trigger a message to tell you should look at the logs. Okay, so in Luigi, for example, you have a built-in system to get an email if something goes wrong. So you get automatically an email with the last Python exception that happened. If you think emails are not cool anymore, you can use Slack notification. So at the end of your pipeline, you say green line, the pipeline went well, or red line, the pipeline was broken. And there are a lot of options to build Slack bots and integrating with Luigi, but I didn't find anything really satisfactory. So starting writing this Luigi Slack component that is a work in progress for Python 3. So long story short, you need a mechanism to say, read the logs if something goes wrong. So in summary, if you are a researcher, you're not an engineer, but can we meet halfway? My point on this is yes, we can, and probably we should. It's important to understand what you're doing. Are you building prototypes? Are you just doing some analysis? Are you writing a paper? Are you building products? And the key point for me is if you learn the basics engineering principle, you can benefit from them even if you're not an engineer and even if you don't build products. In particular, what matters are automation. If a task can be automated, it should be automated because otherwise you're going to end up running things manually and it's going to be boring. And when you're bored is when you make mistakes. And also replicability matters. Things should be replicable, should be able to rerun, reproduce the problem. It's true in science as well. Science should be replicable if possible. And the ways to do that, the simple ways to do that is simply applying the basic engineering principle. I mentioned testing, I mentioned logging, good packaging. So know the ecosystem in Python and know that there are tools to do the stuff that you need to do without reinventing the wheel. And before closing, I just want to mention the slides are on my speaker deck. The Luigi's Lag component is on my GitHub, and then if you want to reach out, I'm quite easy to find. Thank you very much.
So, I have a question about best practice in Python. The typical workflow where you have to take some data and take some raw data, let's say clean them, aggregate them and serve them to a data analysis algorithm or whatever. The typical workflow is composed by these 4 items. So taking the raw, cleaning, aggregating, and serving them. Python offers you both ways, both the object-oriented way, so building a class with 4 methods that do this, or the functional approach, so you can build 4 functions that live independently by each other, but somehow each one is forced to receive the output of the previous one. Which one would you recommend? Since we have had some internal discussion in the company I work for about this topic, I would like to know your opinion. From my point of view, the class is better from client side, so you can just instantiate a class and call 4 methods. But he has the drawback that you cannot see the 4 methods as independent by each other. And the functional approach is more modular, if you say, but you have to handle it. If you're a client, you have to pass the output of the previous function to the next one, which is a bit cumbersome, in my opinion. So I would like to know your opinion about these 2 approaches that are possible in Python.
Yeah, I think there's no silver bullet, right? And there is no free lunch. So usually what I like to do is to have a short iterations, so kind of spot the problems early on and then fix them early on. I think if you work, for example, with a Scrum kind of approach, so you have your sprint and then you set your goals every 2 weeks. That's one way to do it, but it's not the only way. The point is it depends, really. So I don't have a final answer. In general,
one of these 2 approaches are somehow recommended in Python. For example, I know that classes are more useful when you have to model entities, while a data taking workflow is not like an entity, it's like a sequence of processes. So I don't know if in Python there is one of the approaches recommended.
Yeah, I think it's not Python specific, it's more like a design problem that it's more general. And in my case, many of the pipelines, you know, they exist in a bigger context. So we have, say, a bunch of microservices. So we build models that we need to serve through the microservices. And when things gets a little bit complex, I feel more comfortable with classes But if you remember the talk from yesterday about scikit-learn, deploying scikit-learn in the cloud, using the AWS Lambda approach, so you can write just functions. It's also useful if you are very focused on what you're doing. I can't give you, the final answer on this because it really depends, and I would say it's not Python specific. It's more of a design problem, and it comes with experience, which means making mistakes. So I would go with objects as soon as things feels a little bit complex. That's my take on it.
My question is about Luigi. So does Luigi features also scheduling of the task like cron regularly? And if not, what, do you recommend some frameworks, or how do you usually approach the scheduling of the tasks?
Okay, so Luigi does not schedule your task, so you need to trigger the execution of your pipeline somehow. It can be either with a cron job, or if you have a CI kind of tool, you can set up your Jenkins or Travis, whatever, to trigger the execution manually. So yeah, long story short, no. Usually workflow managers, they allow you to define your pipeline, but triggering the pipeline is a different story. So defining the pipeline is one thing, running the pipeline is another thing. And Luigi can be run, so it has a central scheduler daemon that you can use or not. And you can run it as a command from the command line. You can run it kind of wrap into a Python script. So there are a couple of options. You still need to trigger the execution. Usually cron job, if it's something that can rebuild your models overnight or something like that.
Any other question? I have one. Could you please clarify a bit if there is any difference between Luigi or Airflow, such like this kind of tools, and Celery, for instance, for task execution?
Yeah, Salary is much more low level. That's the story. So Luigi and in general the workflow managers that I mentioned, they are much higher level and the interface is much simpler. So you need to take care of just small details. The code that I've shown you is all you have to do, really. So each task of your pipeline is a Luigi, is an extension of a Luigi task class, and that's it. You define your dependencies, you define your output, and you define what you run. That's the end of the story. With Celery, you have a more complex mechanism to send messages, and you need a bit more probably infrastructure for that, and probably you can also scale up more with Celery. You know how to do it.
Any question? Okay, so thank you very much, Marco.